Okay, I think I will begin. It looks like all of our guests have been allowed into the room. And my name is Jennifer Williams, and I'd like to welcome everybody so far that have joined us today. Good morning to some, and good afternoon to others. On behalf of the Canadian Academy of Engineering and National Engineering Month, it is my pleasure to welcome you, the CAE Fellows, members of other academies and organizations, the public and students, to this webinar on ocean engineering. This presentation is dedicated to all engineers across the country in recognition of their excellent work. As I mentioned, my name is Jennifer Williams. I am the president of Newfoundland and Labrador Hydro and a fellow of the Canadian Academy of Engineering. Before I continue with opening comments, I wish to offer a land acknowledgement. This specific acknowledgement was created for use at Memorial University's St. John's campus, and so references my home province where I am today. We respectfully acknowledge the territory in which we gather as the ancestral homelands of the Beothuk, and the island of Newfoundland as the ancestral homelands of the Mi'kmaq and Beothuk. We would also like to recognize the Inuit of Nunatsiavut and Nunatuavut, and the Innu of Nitassinan and their ancestors as the original people of Labrador. We strive for respectful relationships with all the peoples of this province as we search for collective healing and true reconciliation and honor this beautiful land together. For the many of you joining from outside Newfoundland and Labrador, I wish to respectfully acknowledge the traditional territories of First Peoples on which you are all gathered today. Now, to inform our students and members of other organizations who may not be familiar with our organization, the Academy is the national institution through which Canada's most distinguished and experienced engineers provide strategic advice on matters of critical importance to Canada. The Academy is an independent and self-governing and not-for-profit organization established in 1987 and is one of 3 national academies that make up the Council of Canadian Academies. We have over 800 fellows from across Canada, all of whom have made significant contributions to engineering in Canada in the private, public, and academic sectors. I should mention that the views and opinions being expressed here today are those of the speaker and myself, and do not necessarily reflect the official position or policy of the Academy. And before we get started, I'd like to go over just a few housekeeping items and explain the format for our online proceeding today. I'm sure many of you, especially now that we're 12 months into the pandemic situation, have attended past webinars where you will know that you are muted upon entry into the webinar. If you have a question anytime during the presentations, we invite you to use the chat function, and we will do our best to answer your questions. We will hear from all panelists first, and then we will go to questions. Also, for your information, this session is being recorded and will be available on our website. Now, it is my pleasure to introduce our first speaker, Kendra Mcdonald. Kendra is the CEO of Canada's Ocean Supercluster, responsible for driving digital, sustainable, and inclusive growth in the ocean economy. She was previously a partner in Deloitte's risk advisory practice and chief audit executive of Deloitte Global, and she speaks regularly on the topics of innovation, future of work, and disruptive technologies. Over to you, Kendra.
Excellent. All right, so step 1 is always to share my screen. I'll try that first. Hopefully we can see that. So thank you so much for the opportunity to be here and share a little bit of the Ocean Supercluster journey with you. Thought I would start, for those that are perhaps less familiar with the Supercluster, with just a quick video that tells a little story about what it is that we're trying to do.
With the longest coastline in the world, 4th largest ocean territory, and significant Arctic territory, Canada's biggest asset is also its biggest opportunity. Our ocean story has a long history that has helped shape us as a nation, providing a source of food, energy, transportation, business, and a way of life. Today, in the face of a $3 trillion global ocean opportunity, we are answering the call for sustainable economic growth. striving for balance and expanding ocean opportunities while also addressing ocean health. We are building solutions to shared ocean challenges for the global market, developing cutting-edge ocean technology, facilitating greater connectivity, increasing data exchange, expanding talent, capability, and diversity, and making this the best place to start and grow an ocean company. And we're doing this by bringing ocean industries together in a way that's never been done before. Leaders in fisheries, aquaculture, offshore resources, transport, defense, marine renewables, bioresources, and ocean technologies are working together to rapidly innovate, commercialize solutions, reach global markets, and grow the ocean economy. Together, we are advancing Canada's position as a global leader in ocean. Canada's Ocean Supercluster, changing the way ocean business is done.
So certainly part of the ocean supercluster journey is the fact that we are currently facing, or the ocean is currently facing, tremendous pressure. And a lot of that pressure is actually being driven by emissions and therefore CO2 absorption and what that is doing in terms of ocean acidification and rising ocean temperatures and various impacts. So, you know, when we look at, for us, think about our projects, we really think about how do our projects balance the health and wealth, so opportunities in ocean, with making sure that we are continuing to manage our resource sustainably. You heard in the video that we're working to change the way ocean business is done. And really what that means for us is creating an ocean economy for Canada that is more collaborative. So that idea of cross-sectoral collaboration. So the supercluster was really built on this concept that there are several challenges that face multiple sectors of the ocean economy, and those include increasing our reach, so knowing what we know across the country, as well as increasing our international reach in terms of attracting foreign investment and identifying new markets. Workforce development, so lots of challenges on the journey to future workforce in many traditional industries across ocean sectors, as well as the cost and risk of doing business in the ocean. So while these have different flavors depending on the sector, there's a lot of commonality in terms of being able to solve those challenges and being able to develop solutions that are then very scalable globally. We're also looking at an ocean economy that is increasingly digital. And so this, like many other parts of our economy, are looking to digitize, and lots of work to be able to increase our knowledge and data collection in the ocean, as an example, to make it more inclusive. And so being able to have all parts of our workforce able to participate in the ocean economy and address the various challenges and opportunities there, as well as increasingly sustainable. And so we know from a lot of the work that's been done on the high-level panel on sustainability, of which Canada is a part, that actually a more productive ocean, a more sustainable ocean and healthier ocean is also a more productive ocean. So there truly is, you know, an economic imperative as well as, you know, a societal imperative in terms of the health of our ocean. And finally, world leading. So really looking at Canada as an ocean nation, we've been behind in terms of our contribution to GDP from the Canadian ocean economy. We can compare us to other economies around the world. So there is a tremendous opportunity, both in terms of where we're currently positioned, as well as the tremendous growth that is projected. The ocean economy is set to outpace global growth of other parts of the economy. And so this presents a tremendous opportunity for the country. Where we sit today as Canada's Ocean Supercluster, so we're just about halfway through our first 5 years. We're close to 400 members, about $250 million in project value approved, which represents about 50 projects. And so those projects are looking to create over 100 processes, services, and products that those involved are looking to scale to the world. So it's incredibly exciting, and we're trying to roll out those projects as quickly as we can. We share our projects publicly after they have been contracted. We have two main programs, our Technology Leadership Program and our Innovation Ecosystem Program. The Technology Leadership Program is really focused on developing new technologies. And so they are looking at, one, as I mentioned, collaborative partnerships. Incredibly important is commercialization. So looking for commercial outcomes. This is probably one of the biggest challenges for projects, and it's a broader Canadian challenge. We have tremendous high caliber research, but really turning those into commercial opportunities and being able to articulate the market size and the opportunity that exists, developing innovative IP, and really creating incremental opportunities that have benefits to Canadians. Our second program is Innovation Ecosystem. It's a much smaller part of our programming, but is very much focused on trying to address some of the gaps in the ecosystem that allow the entire ocean economy to grow more quickly. So a couple of, I thought I'd focus in just on a couple of projects. So we have about 25 projects now that are announced. And so again, those three big buckets that you've heard a couple of times now. So digital ocean solutions, a focus on digital. And what I would say is when we think about that journey to net zero, digital solutions is a really key part of that, and being able to better leverage technology in terms of collecting more data. So there's much of the ocean that is unexplored. And so being able to collect more data allows us to make better and more precise decisions in the work that we do on the ocean, but also it allows us to improve processes. So if you take a project like Talibut project, for example, that project is out on the West Coast and is looking at bringing artificial intelligence to being able to reduce waste in fish processing. And we know that one of the challenges of food waste is that it contributes to increase emissions. And so if we can reduce that and leverage technology to be able to help to solve that problem, then that contributes very directly on our journey to decarbonization. On our sustainable ocean solutions, perhaps even more obvious connection in terms of that journey is we've got several projects in that space, a lot of focus in marine transport. So transportation overall is obviously a big contributor to emissions, but marine transportation is a very significant contributor, and marine transportation is expected to continue to increase because it is such a key way that we move our goods around the world. So we've got several projects that are very much focused on that. Obviously internationally, marine transportation is focused on a journey to zero emissions over the next few decades. And we've got projects that are trying to help on that journey. So one of those is the Smart Protective Coatings project. It looks at the coating on the hull of ships, both to be able to reduce the drag, and as well as being able to reduce the things that are going into the water, and that reduction of drag also reduces emissions. CATAL, or Project Orca, which was recently announced, that's actually a type of fuel that has more water and less diesel, and they see themselves as a transitionary fuel on the journey to decarbonization, as well as Corvus Energy, and Corvus Energy is looking at increasing the life of batteries. So they're a project with Seaspan to be able to get battery power into larger vessels. Again, that one is out on the West Coast. And finally, not in the transportation area, but also trying to tackle that journey towards renewables is our Ocean Energy, BMT Ocean Energy. And that project's actually looking at trying to reduce the reliance on diesel in remote communities and help them to move towards more renewable sources of energy. So we have lots of very exciting, I think, projects in our portfolio that are helping on the journey towards net zero. And I would encourage you, if you're looking for more information, to check out our website. It has descriptions of the various projects. We see an inclusive ocean economy as incredibly important on this journey because these are complex problems that our ocean is facing, and we want to make sure that we've got the whole economy and the whole workforce really focused on those solutions. We do have a gender gap when it comes to ocean, as well as other underrepresented groups, and so we have several projects focused in this area, including our Indigenous Career Pivot Pilot, which is helping mid-career Indigenous explore opportunities to pivot into an ocean career. We also have our Ocean Allies project, which is looking very specifically on the current state of our workforce so that we can use data to be able to see how our potential solutions are moving the needle, hopefully in the right direction in terms of our workforce. One of the other key things for Canada is we are short, or we are lower when it comes to ocean startups. And so if you want to grow companies, you have to have a high number of companies in the funnel. And so one of our very first projects was really to encourage an increase in startups in the country. And several of those, again, are very much focused in the sustainability space. So we ran a global ocean challenge that attracted almost 160 companies. They're just getting ready to launch their second challenge. So if that is of interest to you, you can check that out in terms of their website. They are looking to grow 40 early stage companies. And they also have the Lab to Market program, which is helping researchers understand the opportunities to be able to build a business, as well as the first full ocean cohort of the Creative Destruction Lab. There's several Creative Destruction Labs across the country. You may be familiar with it. The one in Atlantic Canada has a very specific ocean cohort. So finally, just a couple of things. If you want more information, if you're not familiar with us, please do check out our website. We have a few key upcoming activities. So we've just launched our Deeper Dive, which is a series of podcasts. So the first podcast launched the week before last. The second one is coming this week, and it will be our first project feature as part of that podcast series. We were very excited to work with Amazon Prime. So Amazon Prime did their first Canadian Future Code episode on our Canadian ocean economy and projects, which we were very excited about. We've just launched, I mentioned that Indigenous Career Pivot Pilot. So we've just launched our Indigenous Career Pivot Pilot Journey video that tells the story of some of those individuals that are pivoting to that career in ocean and their experience. So that'll be over the next 6 months. And we are about to have our first article in Canadian Geographic this month. This is a global conversation, and we're really excited to be a part of it in Canada. And one of the other things that Canada is doing is developing their blue economy strategy. So, more broadly, Supercluster is a piece of that. But how do we think about where we want to be as Canada? Where do we want to lead? And how do we want to participate on the global stage? So with that, I look forward to the rest of the conversation.
Thank you very much, Kendra. To make sure everyone can hear me okay. Next, we're going to hear from Peter Noble. It is my pleasure to welcome him. And some of you may know him. He is a naval architect and ocean engineer with global experience in the maritime and offshore sectors. Peter's work has largely focused on research and development, concept exploration, and front-end design across the whole range of engineering for the ocean. He's currently active in the ocean renewables and energy transition fields. Over to you, Peter.
Okay, can we pull up the slide deck? I want to follow on what Kendra said. I think a lot of there'll be a natural melding. Canada is a maritime nation, and sometimes we think of that in terms of our motto as a linear nation bounded by oceans on the east and the west. But in fact, if you go back to the original biblical context of A Mare Usque A Mare, it goes further. It goes from the river to the ends of the earth. And I think that's something we don't always think about Canadians. We have 4 coasts, so we are definitely a maritime ocean-related nation. Next slide. I'm going to give a few slides here talking about shipping in particular, both domestic and international, and both in also the geographical context of north, south, east, and west. Next. So we're active in 2 areas. We have a domestic fleet, which is totally under the control of Canadians, Canadian administrations and Canadian operators, ferries, coastal shipping, fishing vessels, naval government craft, etc. But we also have an important role to play with international fleets in terms of bulk carriers taking wheat away, container shipping, cruise shipping, tankers, and the like. These ships are typically not Canadian owned and operated, but Canada as a port state and coastal state under international law has responsibility to make sure that things are done in accordance with the rules and regulations, many of which are involved with emissions today. Next slide. The Academy has been involved in a little bit with shipping, and I'm glad to see that through this webinar, we're sort of expanding that. I was involved through the Council of Canadian Academies, of which Canadian Academy of Engineering is one of the 3, on a report done 3 years ago, I guess now, on looking at Canada's maritime economy. And I'm not going to go through it in detail, but I would encourage you to go to the CCA website and you can download this report, which is focused mostly on the socioeconomic benefits, but showing how Canada's shipping affects people in the middle of the country as well as the ones on the west coast that actually see the ships. Next, or east coast as well, sorry. Next. Another report that the Academy did that I was involved with some others who are, I think, on this call today, was looking at engineering Canada's northern oceans, because Canada has a unique position as a maritime nation in having a large activity and opportunity in the Arctic Ocean. Next slides. Again, that's available online. Just to put it in perspective, and I'm not going to try to go through the details of this, but roughly the global emissions from transportation account for something like 25% of total emissions, of which marine accounts for about 10. So we're talking about 3% of total greenhouse gas emissions. It's not the big reward, but certainly if we can reduce that substantially, it does make a difference. So that's just to put it in the context of the overall things we need to work on. And of course, shipping requires more transportation to back it up, because in order to get grain out to the West Coast, or coal or iron ore in Quebec, there's a lot of onshore transportation that takes place that is also CO2 emitting. Next slide. So if we look at in the international things, United Nations International Maritime Organization, that should be IMO, promulgates regulations, and Canada, through Transport Canada, is a member of that organization. About 160 of the world's nations are signatories to that. It originated after the Titanic disaster, looking at safety of life at sea, but has grown over the years to look more at pollution prevention and emissions. So we have a number of conventions that are moving in. The ones importantly, the last two are quite important. The EEDI, the Energy Efficiency Design Index, to try and make ships more efficient, and then the energy efficiency for existing ships, which is just about to come in, which are stepwise improvements in ship operations. Next. So let's take a look at Canada. We're actually in a good place in Canada. We have a lot of firsts. We're doing a lot of interesting things and a lot of cutting edge things. We are probably world leaders in providing LNG powered ferries on the St. Lawrence, on the West Coast, and trailer ferries, not just passenger ferries. Next slide. Hybrid and battery powered vessels. Again, we've got cable ferries on the West Coast, and BC Ferries hybrid vessels operating their island class ferries. I think 4 of those coming to service. Next. And we see the Nova Scotia Glas electric ship there. We saw we'll see hear a little more about Robert Allen Limited out of Vancouver, a design company, are world leaders in tug design and LNG. Corvus, we've heard, are about already, are definitely leaders in battery technology and exporting that to Norway. And Robert Allen Limited, again, have done some cutting edge work on looking at where battery powered vessels might fit into the overall spectrum. Things like pilot boats that don't necessarily need to be fully powered all the time. They come in and out of port and spend a lot of time alongside. Next. Looking on the more international scale, we're seeing LNG power being applied to a whole range of ships, cruise ships, container ships, oil tankers, and the one in the bottom left-hand corner is close to home. That's the tote ships that service Alaska out of Puget Sound up and down offshore the BC coastline. Next. We're also seeing a growing interest in the return of sail in different forms. Not the old clipper ships, but kite rigs, Flettner rotors fitted in experimental things, and wing sails. And on certain routes, this can certainly prove advantageous. And under IMO, energy efficiency is recognized that sail power may be one of the components that adds to efficiency improvements and fuel consumption reductions. Next. And I throw this in because there's growing interest in nuclear ships. The Russians, top left-hand corner, have a whole fleet of nuclear surface ships, mostly for Arctic use, where of course nuclear makes a lot of sense because of the power capabilities and the long intervals between refueling. And the other 3 are, the one below the Russian ship is the Otto Hahn, a German ship built in the 60s. The top right-hand corner is Mutsu, which was a Japanese ship, and then the Savannah, the American cargo ship. All of these ships, I think the Otto Hahn may be out of service now completely. The others are not in service, but are still maintained. And it's something with the new nuclear systems that are being developed for onshore, the small modular reactors, molten salt, I think may have a role in the future. Next slide. So where are we going? I think there's two areas in surface shipping where we see things. One is energy improvements to use less fuel of any sort. So this involves not just the ships themselves, but the transportation systems that supply to the ships. Looking at the ship's time at sea. If ships go slower, they use less fuel, but if they go slower, then how do we maintain the flow of goods at a reasonable level? We can look at improved ship design and construction. We heard a couple of projects underway looking at digital opportunities, digital improvements. Hull coatings and cleaning, again, we heard about that. Improved propulsion systems, cargo emissions in oil tankers. It's not always well recognized. The cargo itself is providing emissions which could be controlled. And then a whole port infrastructure improvements so that we don't see ships lying off. I mean, if you ever Google Singapore, the Straits of Singapore, and look at how many ships lie at anchor just waiting for the port, it's thousands. On the other side, on the right side, the other thing to look at is to look at alternative fuels. And so we can look at biofuels, LNG we've talked about, ammonia, and as a hydrogen carrier, we probably got better experience with ammonia in bulk than we have with hydrogen in bulk. But where does it come from? We've got to look at the opportunities for green ammonia to produce without, right now, both ammonia and hydrogen are largely produced from natural gas. But can we produce those from electrolysis using hydropower, for example? Hydrogen can be used as a combustion fuel or as a fuel cell, but we need to grow those sizes to get up to a deep sea shipping size. Batteries, there's improvements in, we mentioned nuclear and wind energy. So all of this activity in all of those areas right now. Next slide. So conclusions is, I think the international marine shipping has recognized the need to minimize and started to implement, but there's still a lot has to be done to reach the targets. In the Canadian context, I think we're actually at the cutting edge of many things. We recognize that particularly ferry operators and naval architects, battery researchers, we're on the leading edge of some technology. What we need to do, I think, as we heard in the last presentation, is how do we bring that to commercial status and get recognized? One of the things I would say, I'm a little disappointed in the present government shipbuilding initiative. And while there are a little bits of activities around this multi-billion-dollar project, there's not really, I haven't really seen within the program itself a net zero target. While the government in its own fleets has declared a target, the new shipbuilding project seems to me that it hasn't really fully embraced that. So that's another opportunity for us. Thank you. I think that's the end of my presentation.
Thank you very much, Peter. We're now going to go on to our third of four speakers, Neil Bowes. Neil is the Vice President Research at Memorial University, which is Newfoundland and Labrador's university. As a researcher, Dr. Bowes' interests include marine propulsion, underwater robotics, autonomous underwater vehicles, ocean environmental monitoring, ocean renewable energy, ice propeller interaction, and aspects of ocean engineering design. Neil.
Thank you, Jennifer. I'm going to tell you a little bit about marine pollution and especially oil spill response, and talk about work that's some work that's ongoing at Memorial University. So a lot of the work done at Memorial is actually focused in the harsh environments because Newfoundland is to the north, and this picture shows the entrance to St. John's Harbour at a time at the ice break up in the spring, that when sea ice can travel south, not all years, but this was obviously a year when there was a lot of sea ice. Most pollution in the ocean actually starts on land, and that's runoff from the land and pollution of people on the land that ends up being washed into the ocean. A small amount does actually start in the ocean with oil spills from offshore exploration and the like. Plastics, as you know, have become very much a part of a concern of pollution in the oceans, as shown in this slide. And I'm going to focus more in this talk around oil spills, the largest of which was actually the spill in the Gulf of Mexico in 2010, which spilled almost 5 million barrels of oil. So when an oil spill happens, the oil spill response must be put into place. There's a lot of assumption that the oil arrives at the surface. Some of it disperses. Chemicals are used to disperse it. Some of it can be burned. Some of it can be skimmed off. As part of a very large, almost $50 million federal funding project with Department of Fisheries and Oceans, a certain number of those projects have actually wound up at Memorial University, involving effectiveness of using dispersants, improved absorption technologies, interactions between oil dispersants and particles, and so on and so forth. The one I'm going to talk about in more detail is one that I've been involved with closely, which is delineation of oil spills using underwater robotics, autonomous underwater vehicles. This is the team of people that we have. This is one of the vehicles that we're using to demonstrate, or to develop, actually, not just demonstrate, develop technology to actually delineate oil that might be in the water. Incidentally, there's more engineers on the front row there than there are on the back row, and I'll show you, hang on. Yes, as this team shows, this is a team of people. And the reason for putting this up is because I always like to put my team members up, but it shows that the project team itself straddles different countries, and the advisors on the project also add to that spread. And one of the things that has happened through the pandemic is the more easy ability to communicate, although this team was well in place before the pandemic occurred. So these platforms like we're using at the moment are a very good way of keeping the team together. So when an oil spill happens, there are four main tasks to respond to those spills that include assessment, monitoring, response assistance, and reporting. I'm going to focus on the first of those. We have a discontinuous plume in the ocean, which disperses, and that plume can, well, it physically degrades, it chemically degrades, and there's also a biological transformation that occurs. This picture shows what happens, or what can happen, when oil is released at depth, as it did in the Gulf of Mexico. So the oil is released. It had been assumed that it would come to the surface, and that response that the slide of response that I showed you shows how you can deal with it when it's at the surface. The problem is it doesn't all get to the surface. And to a great surprise, drawing this spill, was discovered that huge amounts of oil ended up trapped at depth, and required different ways of actually assessing what was actually there, how much was there, where it was. One way of doing that is to use underwater robots, or underwater robotics, autonomous underwater vehicles. But most vehicles today require development to really make them as effective as possible as tools in which one can go searching for the oil and see how far that it spreads. So the work on our underwater vehicle issues has three main sub-projects. The first of which is using adaptive sampling of different features and using sensors from the underwater vehicle. And I'm going to talk about that one mainly here, but our work also involves using multiple vehicles, glider AUVs, and also smaller vehicles, micro AUVs and long-range AUVs, that can maintain a persistent presence in the ocean. So the issue that we're looking for is how, or looking to improve, is how do we make our vehicles more smart and more effective and more able to use the energy storage on them effectively. So, and we're doing that by developing what we call adaptive control. We have on the right-hand side of this slide, the main operating computer on board, which we call the front seat driver. That set up a series of predefined instructions. The vehicle is controlled by that. It's essentially the direct driver, the person sitting in the driving seat, as you in the analogy. It has to maintain its robustness in the operation of the vehicle. It needs to take over if the backseat driver leads the vehicle into danger or error. So then we set up a backseat driver that is able to make independent decisions and generate commands that it then tells the front seat driver what to do. And those computations or those decisions are made in real time. So, for example, you may take measurements from a sensor of say, sonar reflecting from oil in the water column, decide to change the track of the vehicle, tell the front seat driver what to do, and so on and so forth. So, and this slide shows the sort of thing that can be done. So we've got undissolvable substances in the water, which is the oil. The vehicle can sense that oil, the clouds of oil, from advance, say using the sonar. In this case, we are using sonar, and make decisions accordingly. So what this slide shows in the left-hand picture and at the bottom left of that is the vehicle in some kind of search phase. Now we could, and it's more traditional to just map out a sort of lawnmower type path looking for the item that is of interest. But what we are doing here is setting up a more efficient method of searching. In this case, we've got a sort of bumblebee inspired motion that looks pretty random, but actually is very efficient at finding the item of interest. When the vehicle senses the oil, that's the browny yellow splodge at the right-hand side, it then starts to track the oil and go around it using the sonar sensor on board. And all this is done using that backseat driver control, adjusting the direction of the vehicle and recording the results. So this slide shows a sort of enlargement of the oil. The oil is actually not continuous, it's patchy, consists of droplets of different densities. And so what is being done here is the vehicle tracks around in the yellow track, and there are actually two tracks here. It's the same oil patch in both of these pictures, but depending on the various sensitivities that are put into the control, it either tracks closely or further away. Now, this is all simulation. The question is, can one actually make it work in practice? Well, one of our problems is we can't go throwing oil into the ocean, especially not near to land. But we've been doing field experiments in the marine base in Holyrood Bay in Newfoundland, where the yellow line shows the base on the left-hand side there. We, first of all, set up the search and tracking phase. And this is actually a real track of the vehicle running in backseat driver mode, which is quite a significant step forward for a large AUV of this type. We have to have fail-safe behaviors in place so that if something goes wrong, with the backseat driver control, the front seat driver takes over and returns the vehicle to safe condition. And this track, which is shown here, which is the going to different waypoints and then doing the bumblebee search pattern, is what's showing up here. There's overshoot in the pattern, which actually makes the every time the course change is made, there's a little bit of overshoot, which is what gives the wobbly appearance. Now, so our next job, which is to be done this coming year, we've been held up, as you can imagine, a little bit through the pandemic, because we weren't able to get out to the field in the middle of last year, and ended up doing most of those tracks that I showed before in early December last year. But we are planning on being out there over this coming summer with the scanning sonar in use. We're going to use various proxies for oil, and the most likely proxy that we will use is actually micro air bubbles, which we will push out into the ocean. We need a fairly large plume to be able to show that to be able to track it with a vehicle the size of the one we've got. But then, of course, we also have to, it makes sense to use a relatively large vehicle because we can carry the equipment on that we need. And also that's more the size of the oil spills in practice. But we could use other more physical targets as well to show how that works. So that's where I'm going to stop at this point, and you can go over to the next speaker. Thank you very much.
Thank you very much, Neil. And please join me in welcoming our fourth speaker, Sue Molloy. Sue is the CEO president of Glas Ocean Electric. She is also an adjunct professor at Dalhousie University and specializes in sustainable ocean engineering. She's an active reviewer for the US Department of Energy and Canadian national programs. She is currently the Canadian chair of ISO TC8, Ships and Marine Technology, and is the international convener for the IEC committee focused on river turbine performance. Over to you, Sue.
Thank you very much. And I am having the rare pleasure of following my PhD supervisor in a presentation. So this is good. Okay, so I have been working with my company and the team that we have on small craft emissions and electrification. Currently, we're actually working in the Ocean Supercluster Ocean Startup Project, and we're getting a lot out of that, and it's helping to guide us forward. It's incredible how much advice you really need to move forward in these fields. So the vessel that I have here is the vessel that we converted this summer, and it's covered in pretty beautiful indigenous art from this region. It's a fairly prominent artist named Alan Sillaboy. He's a Mi'kma'ki artist, and he developed this for us. It's not actually painted, it's printed on a wrap, and then we wrapped it, which means we can repair it when we want to. So the first thing that we needed to look at when we started thinking about electrifying boats, I first started talking about this with people in Halifax in about 2012. We started to realize that we don't really know a lot about how boats use power, like boats specifically. When I say boats, I really mean under 25 meters in length. So the question came was like, well, we really need to measure before we can start determining what size battery we need to put on board. So the interesting part for me about this industry is that we're really building an industry and building drivers and building the information and building the measuring. So having an academic background has been really valuable for the kind of work that I need to do. So we look at some boats and we're like, okay, well, the boat leaves, it goes, it does stuff, and then it comes back. It's not like a car where you know that they travel 50 kilometers an hour on the highway, probably 20 kilometers to work max, and then they went to basketball, and then they went to the grocery store. So we want to know, what are they doing? So this is a time profile that we started to look at. We got some information from lobster boats, and you can see that there's a big difference. These are just 2 lobster boats in Nova Scotia, and there's so much difference in how they use their power that it's really difficult to predict exactly what kind of power needs they would have. And then I was studying the work that has been done. There was a hybrid tug that was converted, and in California, they did an emission study on it. And this tug, it's the zero emissions tug that was deployed in Rotterdam, I believe, from the company AKA and PEI. And they converted it so that the boat, the tug would operate on electric only when it was traveling to the ship that it had to work with. And then while it was pushing and moving the ship, it would be on diesel. And then the diesel, being in its high efficiency zone for operations, would then charge the battery. So it was a completely self-contained system. So although they only dropped their fuel use by 27%, because they were operating in their emissions range of their high efficiency range, and they're much cleaner burning fuel, they actually dropped their particulate matter by 73% and their NOx by 51%. So this started making me think about, well, what are the opportunities? So I started looking for vessels that had similar kinds of models where they would be doing low speed operations for a long period of time, and then just short bursts of high speed operations. Start looking at lobster boats. And this is a time series that we pulled from one of the lobster boats that we've tested. We've tested over 20 at this point. We've got lots and lots and lots of data, months of data. So you can see that the story that gets told when you look at this data series, you can see that the boat travels to site at about 108, 110 kilowatts. That's about 30 minutes. It's time times 10 to the 4. And then it slows down, it goes down to 0, and the negative, it's fun to show this to mechanical engineers coming from the ocean engineering. The negative torque is just that the propeller was turning in the other direction, but the mechanical engineers get a little panicked when I start talking about negative torque. So we slow down, and the operator stops, pulls their pot up, puts their pot back down, and goes to the next spot. So you can see that the amount of power that's being used in this pot raising and lowering zone is much, much less. And then they have their high power and they transit home. So we started looking, okay, we've got battery only operations opportunity here. So if we left the diesel engine, added an electric motor, added in the battery power that is shore powered, and then it becomes people like Jennifer's problem about where the power comes from. And then we have the potential to actually operate on renewable energy for that period of time. And this is really applying to vessels that are day trippers, that come home to port every night, that could charge at home, and that have significant periods of time where they have low speed operations. So this will give you an example of the route there. So they travel out to their site, they do all their pots, and then they come home. So we converted a tourist boat. So it was a traditional Cape Islander fishing boat that had been converted into a tour boat. The reason for that is because Transport Canada helped us, and they had to work with a boat that transported something, and people count. So we converted it to electric, and as part of the process, we did a before and after study on emissions and noise. This is the motor, just to give you a sense of how small the motor. You can see the brush handle there. We had that to keep the lid off, but I like leaving it in there so you can just see how small the motor actually is. And that motor can run that Cape Islander fishing boat up to 9 knots, which is quite astounding. We deployed a hydrophone, and we ran the boat over the hydrophone at different speeds with different loads, and with three different propellers. So we got a good sense of what kind of a noise was coming from the propeller. The propellers were a brand new propeller, an in-service propeller, and a damaged propeller. So again, lots and lots of data and lots of correlated data. We also did emission studies. The emission studies were the most revealing for us, and then they led into more studies afterwards. We measured, I think we've got 9 components that come out of it, but some of the components don't get measured well because they have been cleared out of the fuel for the most part. So this is an example of the components. If you look here and you see CXHY, that's your hydrocarbons, so methane, one of the worst emission that we can put into the atmosphere for climate change. It's short-lived, but it's highly damaging. And you'll see that the number there is 4,350 parts per million. If you were to take your car to get checked, you'd probably be coming out with somewhere between 150 and 200 parts per million. We had numbers that went up as high as 15,000 parts per million. So we're starting to realize this is a problem. And one of the issues is that we're dealing with we're dealing with boats that have older engines, because we know a boat tends to last 30 years rather than 5 or 8. They're being what I call owner mechanicked, so they're not necessarily being taken in to be professionally mechanicked as they're over their lifetime. And the fuel's fine. The oil, if you overfill your oil, this is where you get high hydrocarbons, and the chance of overfilling oil, it's a pretty common thing. Then we did our testing, and we determined that the boat under electric uses, just performed just what we expected. So when we compared the curve to the diesel curve, we are spot on. We're using the same amount of power and getting the same speed. There's no problems with how the boat's performing. And then we started looking at the noise piece. So we did the subsea noise, the underwater noise, URN is what we call it, underwater radiated noise. And then we were also thinking about the noise above on the deck. We came across this, and I thought that this was a good driver for actually addressing this issue with electrification. You can see there that the green line is the ear injury rate for fish harvesters, so people working on and around boats, and then the blue line is the ear injury rate for the average population. I would like to know more. We're trying to find out why there's a peak there on 61 and 72, but we don't know that. So something happened in 2004 and something happened in 2017, but maybe they did more tests or something. But what it's saying is that electrification as a solution is a really important option because it directly impacts things like the injury rate. It displaces the emissions that are significant at low efficiencies. And then underwater noise, we found that the area that we expected, and these are complicated, I'm not going to get into them, but essentially we were pulling down by 3 to 4 decibels between 4 and 8 knots, which is it's a decibel scale is a log scale, so it's a lot of noise that was being dropped. The other thing that we noticed, which was very interesting, is that the depth of the propeller in the water had a very big impact on the noise. So it wasn't just speed and load and damage of the propeller, but actual depth in the water that had an impact. So there's a lot of information here that will allow us to go forward and test more, but we have enough concrete information to really show that the importance of pulling this diesel noise out of these low speed operations is going to be significant for an environment. Regarding these boats that are out there, the global fishing fleet is estimated at 3.7 million vessels right now. 68% of them are motorized. We're seeing more and more motorizing because of the fact that it's safer, and there's probably a lot more secondhand motors being used. I had a conference trip where I worked with some academics in Indonesia, and they are using 2-stroke engines with leaded fuel, and they're taking old truck engines and sticking them into the ships. So we were looking at what is the opportunity there. The researchers there were getting very concerned that the IMO regulations were not being applied to smaller vessels. And they were saying, we have 50,000 fishing vessels in Indonesia, and if we don't apply these regulations to the fishing vessels, we're missing a huge part of the source of emissions. So over 2 million of these vessels are between 20 and 500 kilowatts, which puts them in the range of boats that could be converted to an electric system. And that could be a hybrid system where you leave your diesel engine and you add an electric motor, or a hybrid system where you have a genset that runs an electric motor. The restrictions obviously are going to be the size of the motor that you want to get. You don't want to end up creating a situation where you have to get a very large electric motor to push the boat at a high speed when 90% of the time it's actually operating at lower speeds. And there we go. I thought I would keep it fairly short and sweet, and thank Transport Canada, Nova Scotia, and NRC for helping the work that we're doing.
Thank you very much, Sue. That was excellent. So now we're going to move to the questions part, which I'm sure some of the audience members would certainly like to get in on this. I do have a couple of questions that have come in already, and I also have a question or two that I wouldn't mind posing to the panel to sort of discuss with them. But maybe I'll start with one question per panel member, and then we'll see where we go from there. I will start with Kendra, where she was the first one, and I'll read out the question that came from one of our attendees. Kendra, how does the Supercluster measure the outcomes from their projects? It's a two-parter, so I'll ask you that one, and then we'll move on to the second one, or you can actually maybe you'll comment on it in your answer. So how do you choose between selecting from a few big projects versus more smaller projects when it comes to the funding that you have? So measuring the outcomes, and how do you choose where you do decide to prioritize and invest?
Yeah, it's a great question. So I think in terms of our outcomes, so we are actually currently working on an impacts page for our website. So hopefully that'll start rolling out over the next few weeks. Most of our projects have been contracted since November, so we're really turning our minds now that they're going into operations, looking more at impacts. However, our 5-year strategy does talk about some of the things that we're looking at. So the creation of products, services, and processes, global reach, engagement of workforce, IP creation, new partnerships. So those are the types of things that we're looking at, but we're also now trying to, now that we have our portfolio, thinking through what are some other measures that would be of relevance. In terms of large or small, so I think when the Supercluster started, I think there was a vision of fewer larger projects. And that's where it started. But any size project that meets the requirements can come through our core program, and we have an open call process, so any project, anytime. But we very specifically, as a response to the pandemic, when we saw a lot of the impacts on the ocean sectors, whether it was transport or fisheries, offshore oil and gas, said, you know what, we need to do something. We need to do something now. So last May, we launched our first call program. It ran for 8 weeks. It was targeted at smaller projects in specific areas of digital remote operations and environmental technologies, to the extent we had a crystal ball to try to imagine what was still relevant in the world of COVID. And we really pushed on trying to get smaller projects that could include, smaller scale companies and really shorter timelines to really drive activity at a critical time, we thought, for the ocean economy in 2020.
Excellent, thank you, Kendra. I'll move over to Peter with a question from the group. What recommendations would you have for a vendor approaching the innovators and early adopters in the marine space to help develop solutions around their GHG emissions?
Good question. I think there's actually quite a lot of activity ongoing already. If we're looking at some of the vendors of marine equipment, like ABB, who do electric power equipment, Wärtsilä out of Finland, who develop marine diesels, they regularly have contact with innovators through universities or through mechanisms like the superclusters, which are those kind of mechanisms exist in other parts of the world. It's a truly international issue. I think also people like BC Ferries have been pretty open to listening to people if they have a story to tell that can improve their efficiency. So I think it's a matter of making direct contact. So the vendor, if he's already in that business of selling marine equipment, I would suggest contacts people like the Supercluster or Memorial University. Another route would be through the classification societies. We have within the marine space this unique concept of independent classification societies. So people like ABS and LR have mechanisms for actually introducing people between the innovation and the vendor space. They work with the vendors all the time. So I think that would be the kind of areas to explore.
Okay. Thank you, Peter. I'm going to move over to Neil. And I'm probably going to push a couple of questions together. Can you comment some more on the range and endurance of autonomous underwater vehicles that you've are starting to explore with and are being used, and how are they actually operated? Are they from a ship nearby? Are they on ground?
Thank you. The range and endurance varies with the design of vehicles. The very large vehicles, like the one I showed in my slide, has an endurance possibly of about 24 hours max. It depends how much battery is on board, and they're a fairly heavy user of energy, but that enables you to put on a whole variety of sensors and test things out like we're doing. So what it really means is that you need some kind of, you either operate it from shore like we're doing with a small tracker boat, or you have to take it offshore with a fairly large ship, as you can imagine, that's able to carry and launch the vehicle. So that's one end of the extreme. The other extreme is to have a vehicle that can operate over long periods of time, because if you can do that, in the project that I talked about, which is to look and track oil, you can leave the vehicle out there for periods of time, and vehicles that have that type of range or endurance are the glider fleets, or some fairly low-speed propeller-driven vehicles that can operate over 20-30 days at a time, but it's limited as to how big the sensors can be, and so on, because of the amount of power draw down on the battery capability again. Where we need to get to, though, is how you could potentially operate a vehicle with rechargeables on board and spend a period of time recharging. There have been solar-powered AUVs, for example, but they're not in general, they've been research vehicles, not in general operation.
Okay, thank you. I had a question on to the side here for Sue, but there's a question that's just come in from the group as well. I think I'll pivot to that one. And I think it's really regarding the noise pollution. And can you comment on the noise pollution and as you understand how it might affect various animal and plant life at various oceans? And do you have any perspective on if there's any level that we're aiming for with regards to noise pollution?
You want me to, I can answer that one. Do you want to?
Yes, please. Sorry, yeah, to you.
So I'm not a noise expert, but I've been spending a lot of time with Jesco over the last few years, and I've learned a little bit. The piece that's very exciting for me is that we had this really interesting opportunity, which has been duplicated during COVID in September 2011 or 2001, excuse me. And when there's a researcher out of Maine, and she researches the stress hormones in whales by collecting whale poop that's floating on the ocean. It's pretty exciting research that she does. And she uses her dogs to find the poop. She takes in samples of the poop, and then she measures the cortisol and the stress hormones that are in the poop. And what they found is during 9/11, when all of the vessels were put into harbor, there was a 600% reduction in stress hormones in the whale population. So that was the most concrete evidence that they've had. And then because we've had such a drop in fleet activity over the last year, there's actually been an international group working together that have been pulling in researchers that can go check in their areas and see what research they can do to take advantage of this moment in time. Everything from getting hydrophones down so that they can understand how much noise there is, and understand the effect and the impact on the animals. We do know that whales, I mean, the focus has often been on whales, and they're easier to study, I think, than maybe some of the plant life and some of the smaller fish. But we do know that whales in the northern hemisphere, where we have a lot more ship traffic, are skinnier and appear to be more stressed than whales in the southern hemisphere. So we know that there is an impact. And we do know that every 3 decibels has the power potential of, this is where I start talking about things I don't know very well. So as we every 3 decibels, 3 to 4 decibels, you have the power potential of the sound. So we do know that we want to get down significantly. I'm not sure what that is. There's a lot of studying on background noise and what's natural noise. Like if you have a high flow region and a lot of rocks and cobbles and stones all turning in the ocean, that's going to be a very noisy environment naturally. Yeah. So the people who are doing this kind of research are really looking for ways to try and understand the background noise, which is what not having vessels out there allows you to do, and then seeing what kind of an addition. So it's not going to be a general this is the number we need to get at. It's going to be, how do we reduce it, and where's the goal? And I think I believe they're still working on that, unless someone else has information.
Okay, thank you, Sue. I'm going to pose a question probably for discussion with the panel, and then we'll go back to, I think, because there's definitely some questions there from folks for individuals. But I wanted to talk a little bit about, I think when you think about all of your presentations today collectively, there's both a need to do this, but also an economic opportunity. And, can you comment on the profile that this economic opportunity probably has within the country? And I'm sure this certainly is near and dear to Kendra's heart, and obviously the reason why the country has created the supercluster. But I wouldn't mind hearing about, what can we be doing more of to highlight the opportunity as it, meets the need. So I'd ask the panel members to join in and offer any comment on that. And what else can we be doing as advocates?
I'm always happy to say something. So feel free to stop me if you want to. I find that we have some extraordinary training in this country. We have really strong researchers that have done very important work, and groups like the Ocean Supercluster are helping to take those ideas into innovation and into products. But one of the challenges we have is we are very spread out. We're a very big country, and we have a lot of small companies that are trying to do their thing. So finding ways to help small companies grow big enough to be able to make a difference, I think is critical.
Mm-hmm.
Maybe I can add too. I think there's been a lot of recognition of Canadian expertise outside Canada, to some extent more than inside Canada. I mean, I look at Genoa, who are there in Newfoundland doing great work down on the Gulf Coast. Look at Robert Allen, that are probably 50% of all the tugs in the world are to his designs from the West Coast. International Submarine Engineering out in Port Moody. I mean, lots of that, but it lacked recognition, at least at a national level and at a political level. So I think that's one of the things, maybe through the academy and seminars like this, where that profile can be raised, because Canada has a good profile, but I would say it's got a bigger profile outside Canada than inside Canada for the ocean sector.
I think that there's tremendous expertise in Canada, and there are also successful companies on both coasts and across, but mainly on the two coasts. We don't always support our own as strongly as we might. We often buy things from overseas because for some reason we think they're better. So we need to perhaps work more collaboratively, more supportive of each other. And when we look at some other countries that do that, you see tremendous success in that. I use a classic example of Norway, where there's perhaps more collaboration, perhaps enforced in some way, whereas there is a little bit of a tendency in Canada to cut each other's throats, so that, or to compete when we should be collaborating. And I see Kendra smiling, because that's one of the challenges, I think, for the supercluster as well, in getting us to all toe the line a little bit and support each other.
Yeah, so maybe I'll round out the comments. I think those are all great observations and align with what we see from a supercluster perspective. I think, we often hear the comparison to Norway, and one of the things that I find very interesting is 80% of their population is on the coast, and about 20% of our population is on the coast. So there are a lot fewer Canadians that are waking up every morning and thinking about ocean. And so there is just a huge amount of awareness raising to do, and to have us think about ourselves as a marine nation for a lot of our decision makers. One of the things that we saw with the Future Code episode talking about Canada and ocean was how many comments that we got that said, I had no idea this was happening in Canada. I had no idea this opportunity was here. This is so amazing. This is great. And I think, to Neil's point, helping everyone understand that the competitor to Nova Scotia is not Newfoundland or Vancouver, or the competitor to Newfoundland, same thing, and that this is a global market. And then connecting to Sue's point, the more that we can get the small and medium enterprises to work together to build a bigger solution that they can then scale globally, the better off we are as a country. So that is a huge amount of culture change to really maximize, I think, the opportunity that exists for us.
Okay, thank you. Somebody does have what they are suggesting is a bit of an off topic. So I'll probably park that one and come back to it if we do have time. And that was with regards to aquaculture and probably those opportunities. But I'll jump back to some of the other questions. And I am going to try to spread around the wealth with regards to specific questions versus panel. So this one is for Peter. And can you, as the person asks, can you comment on the status of fuel regulation changes to international supertankers and the degree of compliance that is indeed being achieved?
Yeah, the International Maritime Organization basically promulgates regulations under the auspices of the UN, and Canada, of course, is represented as one of the voices of the table. There's a number. There are emission restrictions on or use of low sulfur fuels are required now. NOx emissions, use of scrubbers, all of those are in place and progressively being enforced. Typically, because there are 50,000 deep sea ships in the world, it takes a little time to move things along. They are long-lived assets, typically 20, 30, 40 years. So it takes a little time to implement. But I would say that implementation is going well. It's enforced by the flag states, the ships owned in the country, but also in the last 2 or 3 decades, port states. So Canada is a port state, and a ship that could be an international ship that comes into Halifax or into Vancouver is subject to inspection by the port state authorities to make sure the regulations are being followed. And so by and large, I think these are policed reasonably well, and they are being followed. And there's been a big market in things like fitting scrubbers to ships. We have to be careful because sometimes regulations are put in without enough engineering science behind it. For example, when we started looking at low sulfur fuels, there was no capacity in the world to produce the sufficient part of low sulfur fuels in the refineries. And so that took a while to implement. And we see the same thing in infrastructure, battery, and I think you made a comment, Sue, about plugging into the shore power. Well, that's okay, but if we all do that, there's a lot more shore power we need. So Jennifer's going to have to help out there. So we need to remember that. In general, I think the compliance is moving in the right direction, although there are always little blips. Just recently, there's an interesting thing where, again, the class societies measure fuel quality when it's loaded onto ship. But there have been some incidents where low sulfur fuel was being produced by simply mixing aviation fuel, which is a surplus because the planes aren't flying, with really low quality fuel to produce the spec required. But actually, when you burn it, it wasn't giving the desired results. So people have been policing that now too. So I think in general, these international regulations, they're somewhat slow to implement simply because they're international and everybody has to agree. It takes a while for everyone to make things happen. But I would say in general, I think we're moving in the right direction, but there's still a long way to go.
Okay. Thank you, Peter. I'm going to go to a question now for Kendra. I picked up on something in your presentation, and I was wondering if it was deliberate or not. You said your first 5 years. It alluded to sort of 5-year approach, and then one of your other answers was, you started probably thinking it was larger projects, and then you have shifted to the smaller. Do you have sort of a next 5-year view or even a 10-year view of where the organization is headed? Oh, you're muted right now.
Talking to myself. When the superclusters were first established, they were established with GDP and job goals out to 2030, and the first 5-year mandates out to 2023. So I always think about us at least trying to get to the 2030 goals. I think that, certainly based on what we're seeing today, that the digital, inclusive, and sustainable all resonate and will continue to resonate for the next 5 years. So how do we continue to double down? I think one of the things that we'll see is, when we started, obviously, we're all things ocean, but more and more for Canada to be world leading, we're not going to be world leading at everything. How do we pick our spots, working with industry and really double down on those to continue to be able to grow and to continue to be able to lead? So I think those are pretty high level, but that's what we see is the vision still holds, but there's ways to be able to now double down on some of those areas. And with the small and large, we'll continue, I think, to see both. So we recently announced a project in aquaculture a few weeks ago. That is quite big. But now we're seeing, I think we'll continue to see more of a mix of large and small.
Great. Okay, thank you. I do have another couple of questions here. This one I think is for Sue. And what can you comment on the kind of impact that we could see if we were indeed to really invest in, hybridizing or electrifying the fishing vessels as where you're advancing that research? Any comment for the country?
Oh, for our country, absolutely. And to pick up on what Peter was saying about shore power, what we need to do when we think about electrification is we have to make sure that we're in the full electrification space. So vessels provide an incredible vehicle to grid opportunity, working vessels, because they're out in the morning, they're back at 2 or 3, and they're there for the peak. They're there to do micro peaks. They're seasonal. Most fishing boats go out 150 days a year maximum. So that means that you could potentially have 100 kilowatt hours of battery space inside vehicles or inside vessels sitting at one location that can be wired by itself. So when you push it into the entire electrification space, all of a sudden it's a lot more attractive. It's significantly more attractive to do vessel to grid using working boats that are day trippers than it is to do vehicle to grid with somebody who has to take an emergency trip to, drop off the basketball gear to the kid that forgot it or something, right? So there's a lot of opportunity in seeing the boat as a piece in the energy space. When we start to look at what the opportunity is in Canada, in the Atlantic provinces alone, and we have the majority of boats here in the fishing sector, we have 15,000 vessels between Quebec, Atlantic Quebec, and Newfoundland that are in the 35 to 45 foot range. And majority of those boats are day trippers by the nature of their size. You tend to be bigger if you're going out for a few days. So if we were to convert all of those boats to a hybrid system, the back of the envelope calculations we're doing, because we're building those calculations right now, is we believe they're putting out about 2 million tons of CO2 a year. And if we were to remove 40% of those operations, then that's 400,000 tons of CO2 a year. So these are the kind of numbers that are possible. And they're not in the equation because people have not been putting them into the equation. They're kind of out of sight, out of mind. I've had that happen. Don't worry, my dog's acting now. We don't have any catalytic converters on fishing boats or any small vessels. When we develop scrubber technology, they go onto ships, and there's compliance, and there's inspection, and there's regulation. When we put scrubbers onto coal fire power plants, there's inspection and there's regulation. There is no regulation in this space. We don't know if people are running around with a 30-year-old engine that is constantly overfilled with oil because it's always leaking oil. So there's huge opportunity to actually drop emissions here in Canada, and not just CO2. It's more than that.
Thank you. So I'll have another quick one for Neil, and then I'll probably ask a panel question, and then we'll do a wrap up with everybody. I can't believe we're running out of time. Neil, I know you did touch a little bit on this. We can't just throw oil out into Holyrood Bay to do a test. But can you expand a little more for the group on how do we indeed test technologies for oil spills if we can't actually release the offending product into the ocean?
Well, the work we've been focusing on is looking at proxies, something that resembles the reality. That's for the everyday tests. There is an attempt to get a permit to do a limited oil release experiment, but it can only be for a short time, and then it would have to be cleaned up. The other area that we're really excited about is to use a naturally occurring seep. And on the east coast of Canada, the biggest naturally occurring seep is actually off Baffin Island, which releases tons per day and has done for 500 years or something. So that's really exciting because potentially, but as you can imagine, it's a bit of an expensive operation to get the vehicle up there and so on and so forth, but we are looking at that as well. So making use of what's available, essentially.
Thank you. Okay, I'll ask a question, and then again, if the panel could just comment on it each, and then I'll circle back with, again, a closing comments to you all. This question, I'll read it out, is the ocean has acted as a moderator for climate change impact by absorbing CO2 and by acting as a sink for the heat. Ocean warming and acidification is and will continue to have significant impact on how we live by the oceans and how we use the ocean resources at our disposal and how we benefit from the economic opportunity. Could you comment on what kinds of measures are possible to reduce the impact of the changes in the oceans that will therefore then have an impact on how we live and thrive? And anybody can go first.
I can start.
Sure.
We have to think of the oceans as being finite. There's been a tendency, because they are so large. I mean, if you go out on the ocean, as many of us do, it seems huge, but then you can be 1,000 miles from land and you see a sort of plastic bag floating by, you realize it's not quite so huge. And or you send your AUV down with cameras on it and you see a Coke can sitting on the 4,000 meters down. You realize that humans have had a huge impact on the oceans, and we have to start to stop using the oceans as a rubbish dump, essentially a garbage dump, and we need to stop at source, which was why I showed the slide saying that most of the pollution in the ocean starts on the land. Of course it does. It's obvious if you think about it. We live on the land, but we've got rivers taking pollutants, physical objects as well as chemical objects and all kinds of things out into the ocean. And we can't treat the oceans as infinite.
Yeah, I can maybe add to that as an engineer. I think there's two parts to it. One is exactly what Neil's saying, is we need to minimize our impact so that the distribution of whether it's pumping hot effluent waters from a plant or plastic emissions, those kind of things, we can control that. But there are things we can't control. The ocean is huge. I tell when I give presentations that really I have it in good authority that people on Mars call this planet Ocean, not planet Earth. There's a lot more ocean than Earth. And so there are things we can't control. And as an engineer, I see we need to, which is what humankind has done, adapt. So we need to do both things. We need to minimize our negative impact. We also need to be ready to adapt. And we have in the past. We've seen rising sea levels. We've seen the Dutch manage to drain their whole country so that Holland can exist today. So there's the two parts of that, I think. One is the minimizing of the negative effects, but also recognizing there are some things we can't control and we should be doing engineering studies and work to make human existence possible.
I can go next.
Sure.
Yeah. Okay. So when we look at the ocean as a source of food, which it is for the majority of the population of the world, I believe 70% of the population of the world gets their primary protein source from the ocean. We are really starting to already see that impact of global warming and acidification. And we can see it directly in the lobster fleets, because we know that the Maine and a lot of the folk down in New England used to have a very robust and healthy fishing community, and now they're going out and the shells are thin and they're not seeing the fish because they're moving into cold climates. So as we see the food sources moving in the ocean, proper management will bring these food sources back. But one of the stats that when I was looking up the fishing boats, we're going to be having 1 million more fishing boats over the next 20 years in the water, with fewer and fewer fish to catch. So I think what's really important is that we efficiently apply funds and support to the technology that we need. We don't want to just blindly throw things at these problems. We need to be thinking about if we are going to be electrifying and putting in a lot of money into a bunch of fishing boats in an area, well, will they even have a fishery in 5 years, and what would that look like? You need to make sure that there's versatility in the technology that gets applied, and we need to be sure that that we're doing as much as possible now to do things like stop the small amounts of oil that get in. I mean, do we know how much of an impact, say in Indonesia, 50,000 fishing boats that are dribbling oil from their ballast water, how much of an impact does that have compared to an oil spill? Like, we don't have enough measurement out there to really understand that. So we need to understand what is the impact of the small stuff, because when you add that all up, it becomes big stuff, and we need to be able to efficiently apply the funds we have, because we don't have an infinite amount of money to solve these problems. We need to really efficiently apply it. And my feeling personally is that we need to be applying it to things that will make a difference right now. And obviously we want to have the solutions for the future thinking, but we do want to be looking at practical engineering approaches to solutions that we can fix right now with technology we already have.
So maybe just two final comments. So I mentioned the high-level panel on sustainability. So they have come out with reports on what the things can be done for the ocean to heal itself. So understanding what those things are and how that's relevant to particular communities, I think, is important. And the other one I'll mention, you know, when we think about every second breath that we take coming from the ocean, helping everyone understand the role of the ocean in climate change and how important every decision that we make is to what happens in the ocean. I think sometimes the more removed we are from the coast, the less we're thinking about the decisions that we're making, the impacts they're having. And to Neil's point, those things all have trickle down effects that go right into the ocean. So really understanding that, I think, and raising that awareness, ocean literacy, and all those things is incredibly important.
Excellent. Thank you, everybody. So I will come back to the panel for like a 30-second wrap up if there's any final messages you'd like everyone to walk away with. But before I do that, I'd like to ask you to complete, Anne-Marie's going to help me here, I believe, the National Engineering Month poll. It'll only take you a few seconds.
All right, thank you, Jennifer.
Great. Okay. So I am going to go back to the group in the way that we did have you do your poll, and just a few second wrap up, 30 seconds or so each, for any final comments that you would like us to walk away with today. I know it's not easy to take everything that's in your mind that you'd like to communicate, but if there's anything that you'd like to clue up with. Kendra.
So I would just say we really are just scratching the surface of the ocean opportunity. And I think we are seeing building momentum, and now is really the time for us to go hard. We're seeing this global conversation accelerate, you know, all around the world. And I think now is the time for Canada to really step in and take a leadership role in that conversation.
Thank you. Peter.
Yeah, I support that. I think it's come through both in the questions and the, oops, sorry here. Is that mine?
One that, yeah.
Sorry, come back to me.
Okay, sure. Sorry, Neil, did you want to jump in?
I can jump in, yes.
Okay.
I think recognizing the oceans especially are a global issue, and so there is expertise right across the oceans. It's like our pandemic problem. We'll only solve the problem if we act as a world instead of independently. So it's the same with the oceans. We can't make an ultimate impact on, say, pollutants in the ocean unless we act in an international way. And we need to support each other to do that, because each country has its own problems. Some of the issues that are relevant to third world or developing countries, as we say these days, are not the ones that we have in countries like Canada. And so we need to be aware of that and to change the approach appropriately. So, you know, we're aware that a lot of plastics comes from a very few numbers of rivers in the world, but that's not all of the problem, but it's where a huge amount of the problem is. But unless one works with countries that have that type of problem, for example, some of the Indonesian rivers, then you haven't really solved the problem for the world, and the oceans are a world issue, not a country nation issue.
Great, thank you. Peter, did you want to, are you good to go? And then I'll clue up with Sue, or?
Sorry about that interruption.
No worries.
I think I agree with that. And I think earlier in my career, I worked with FAO in Francophone Africa and Southeast Asia. And I would think Sue's on a good thing there, because there I learned a lot more than I taught. Because there's a lot of indigenous technology that recognizes the limitations of fuel availability, construction materials, and they're creatively overcome that. And through that also, I think there's been a lot of work done in terms of what you say, the total world fleet. We sort of focus on the big ships because they're visible and we have a way to control them. But in fact, it's all ocean users we need to be concerned about. And there's lots to learn from people from third world countries. I know I learned a lot about building canoes in West Africa that FAO was never able to teach them. They knew better than we do. And in fact, the same in Canada. I mean, we look at the indigenous craft we have throughout Canada. There's a lot of cleverness built into those that we kind of put in museums rather than use for our future.
Mm-hmm. Thank you, Peter. And Sue.
I think I'm going to say the same thing everybody else said, but in a slightly different way. We need to really look at everything as a system, and we need to understand the systemization solutions and the systemic problems. Because in engineering, we tend often to go into our silos, and people are very happy when they can drill down into their piece of technology that they understand. But the one thing that I've learned being in the renewable and sustainable space for a long time is that everything is interdisciplinary. And when we're talking about, as Neil was saying, those rivers in Indonesia, we need to be talking to wastewater or waste management people to solve the ocean problem. So we need to really understand the interdisciplinarity of it, the system thinking, and we need to start taking that higher view, because it's my belief we have all the technology we need right now to solve these problems. We need more technology and iterations and different versions of some of that technology, you know, as we go forward, but we have enough right now to solve the problem we have. What we don't have is the new way of looking at it through systems thinking.
Thank you, everybody. I'm sure I speak for everybody sincerely today that this has been an excellent panel. It's not my my normal niche, but boy, did I learn a lot. And I think you've awoken some new interests in me, and probably even some areas for me to pursue within my role. So I thank you for that. I know everybody who joined us today does thank all the panelists for taking the time to be here with us and give us your thoughts. And I obviously thank the participants who have decided to join us today. So it's certainly all the questions that were coming through. It's made for an informative talk. Thank you very much, everybody. And hopefully we'll see you at the next event. Take care.
Thank you.
Thank you all.